Hello guys, my name is Desmond and I welcome you to my lesson for today where we will be looking at your mathematics. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very much important because what I'm about to say it's massively massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, Kabilo, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Massively important, ladies and gentlemen, over there. So, okay, let's see. In today's lesson, we'll be looking at, obviously, mathematics. You can see over there, trigonometry. It's exactly what we'll be looking at. So, obviously, I'm just going to quickly take you through an introduction, and then towards the end, we'll be doing some exercises in preparation to exam type of question paper. So, let's see. Obviously, from the lower grades, you did realize that when we talk about trigonometry, we are simply referring to a measure of a triangle. Remember, trigonometry, we are only interested in the relationship between the sides, side 1, side 2, side 3, and 3 angles. So it's more like when we study trigonometry, we are actually studying the relationship between the sides and the angles, whereby those sides have got the names being opposite, adjacent, and hypotenuse. So remember, guys, only when we are dealing with a right angled triangle, that's when you can involve sine, cos, and tan, and also theorem of Pythagoras. Only if you are dealing with a right angled triangle. Most importantly, when we are dealing with a right angled triangle, having that, you already know that the side opposite to that 90-degree angle is what we call hypotenuse. But you cannot tell which side is adjacent and which side is hypotenuse. If you have something similar to that, you can only tell that this side opposite to the 90-degree angle is your hypotenuse, but you can't know whether this is adjacent or this is adjacent or opposite until you are given a reference angle. If they say the angle is there, that's when you know this is now adjacent and this is opposite, because it's opposite to that angle there. So can you see here, you don't have a reference angle, meaning you cannot tell which side is adjacent, which one is opposite. But if they say the angle is there, that's your reference angle, then you know your adjacent is there and then opposite is there. We say it's opposite because it's opposite to the reference angle. But remember, we have discussed all of this when we started with analytical geometry. So in today's lesson, we are actually going to be going a bit deeper, where we talk more based on what we call the cast diagram. So it's more like I'm preparing you to those type of questions where, for example, they say a sine of 180 degrees, maybe minus angle theta, multiplied by maybe cos of, let's say, 360 degrees minus, maybe divided by, let's say, a tan of 180 degrees plus an angle, where you need to simplify all of that. So after we are done with all of those, that's when we'll be moving on to proving and everything. And most importantly, guys, remember, today you are attending extra weekend classes, meaning you will be studying ahead, whereby on our Monday to Friday lessons, we will still redo what we are currently doing now. So Xtra classes helps you to study ahead, which means when you do these things in class, you will have a better understanding. When you also do them again on our Monday to Friday classes, it's going to be as if it's a revision. So that's how you develop a better understanding on certain chapters. But now let's go deep and quickly talk about what I've just referred to as what we call the cast diagram. Remember, guys, we will at all the times refer to our Cartesian plane, where we are having 4 quarters, namely 4 quadrants. So this is the first quadrant, this is the second quadrant, this is a third and fourth. And remember, under a trigonometry, we said this is where a right-angled triangle is involved, meaning we will talk more about sine, cos, and tan. And these are what we call the trigonometric ratios. So every time when you hear me saying trigonometric ratios, I'm talking about sine, cos, and tan. In addition to this, that's when you can also include a theorem of Pythagoras. But very quickly, let me indicate to say, in the first quadrant, all the trigonometric ratios are positive. So that means all the trigonometric ratios, which are 3, are positive. And then in this quadrant number 2, it is only sine which is positive. Here, it is only tan, which is positive. And then here, it is only cos, which is positive. So, because you are having letter C here as the first letter, A here as the first letter as there, and then T there. That's what they call it, cast diagram. So whatever that I'll be talking about, it will be based on that, and it will be easily explained based on that. Remember, guys, what we are doing in today's lesson is just to take you guys through an introduction where in the end you will understand how I'll be solving certain problems, because they are all based on what I'm going to explain to you in today's lesson. So very quickly, let's move on to the next part of our lesson. But before I do that, can someone just indicate if you guys are able to clearly hear me? And again, can you still be able to clearly see there?
Yes, it's clear.
Last one to confirm.
Yes, sir, it's clear on my side.
Okay, 100%. So now, I'm about to talk about what we call reduction formulae. Reduction formulae. So maybe let me quickly remind you that on our Cartesian plane, we know that starting from there, we are having our angle being 0 degrees. And then there, it is 90 degrees. We are having 180 degrees there. And then we are having 270 degrees there. And then this is 360 degrees there. So it's more like on a Cartesian plane. If you start from there, the angle is 0. And then it increases, and then up to there, it's 90. Increases up to there, 180 increases, 270 increases, 360 degrees. So it makes a complete circle on that line. So let's see. Now, the reduction formula, what are we talking about there? So we have reduction formulae, but maybe before I even go deep, let me quickly explain to you what is meant by reduction formulae, because the moment you understand that, it's going to be easy to follow as we continue. Listen very carefully. Reduction formulae we actually use these formulas to reduce the trigonometric ratios of any angle to an acute angle. So, Charlotte, maybe let me make it simple so that everyone can easily understand. Remember, you could have, let's say, sine of whatever angle. If this angle is more than 90, we use reduction formulae to reduce it to become an acute angle. So that means it's very much important that you remember that in the first quadrant, those angles are called acute angles. I think this side is obtuse angles. You need to remember those. Here, what is it? Is it reflex? I think it's reflex angle. And then in the fourth quadrant, you are having, what is it? Revolution. I think it's revolution. So here comes the question. If let's say we have sine 210 degrees, this angle, what is the name of that angle? Is it acute, obtuse, reflex, or revolution? You just ask yourself, does it fall between there, or between there, or between there? Then you give me the name. Sine 200, what is the name of that angle?
Reflex.
100%, it's a reflex. So now, because it's a reflex, Jackie, it means if we want to reduce it to an acute angle, that's when you use reduction formulae.
Okay.
So that means any angle which is greater than 90 degrees, we use reduction formula to reduce it to an angle which is less than 90. So it's more like whatever angle, if you have tan of let's say 316 degrees, ask yourself this question: can we reduce that angle? Yes. Why? Because it is greater than 90. What about, let's say, cos of 13 degrees? Can you reduce this angle? No, you can't. Why? Because already it's an acute angle. So in short, listen very carefully. We use reduction formulae to reduce a trigonometric ratio of any angle as long as it's greater than 90. We reduce it to what we call an acute angle. Acute angles are angles which falls between 0 and 90. Does it make sense what reduction formula are used for?
Yes, sir.
I think as we go deeper, it will make some sense. So let me continue in the meantime and say, for now, let's focus on the reduction formulae along that line of the x-axis. And then later we will look at those along the y-axis. Okay, let's see. We have they call them function values of, let's say, 180 degrees minus an angle. This is our first reduction formula along that line. And then the other one is going to be 180 degrees plus an angle. So it's more like I'm giving you guys a list of reduction formulas. So that means if you have an angle which falls in the second quadrant, for you to reduce it, you're going to say 180 minus that angle because it falls in the second quadrant. But if you have an angle which falls between 180 and 270, that's why to reduce it, you're going to use the reduction formula of 180 plus an angle. Why? Because that angle, it falls in this quadrant. Let's maybe try to be practical and test how to work out that type. So let's say, for example, you are having sine of 180 degrees minus an angle. Because of this, you should know in which this angle falls. Here comes the question. 180 minus, in which quadrant does that angle fall?
Quadrant 2.
Quadrant 2, 100%. So that means, you remember in mathematics, we always don't want to see the brackets. So that means when you use a reduction formula, you are actually trying to now remove those brackets. Then you ask yourself, in this second quadrant, is sign positive or negative?
Positive.
It's positive. That is why you're going to then have positive sign of that. Let's maybe try another example. Remember, only three. It's either it's sine, cos, or tan. Those are the three trigonometric ratios. Maybe, let's say, if we are having cos of still 180 degrees minus an angle, in which quadrant does this angle fall? Obviously, second quadrant. Here comes the question. Is cos in that quadrant positive or negative? It's negative because we know it's only sine which is positive. So that means cos is negative in that quadrant. Then you're having negative cos of an angle. That's how you reduce that. Lastly, let's have a look at tan of 180 degrees minus an angle. It might be boring, Bantu Bagiti, but trust me, we do need to do all of that so that in the end, we are all on the same page. So let's see, you say, in which angle does this fall? That is the format that you follow. In which angle does this? So in the second quadrant. Then is tan in the second quadrant positive or negative? It's negative. That is why you're going to say negative tan of an angle. So that's all that you need to know regarding that reduction formula. Let's quickly move on to this one. Jackie, remember, honorable member, for now, you can just allow me to preach the word of God. You will intervene during that time of questions. So for now, it's just so that we can quickly make sure that we complete our lesson on time. So remember to remain muted, honorable member. Okay, let's see. So now we are having 180 degrees plus that. So that means let's test it. Let's maybe start with a sine of an angle. No, obviously 180 degrees plus an angle. So you're going to ask yourself to say, in which angle does this fall? It falls in the 180 plus, being the third quadrant. So in the third quadrant, is sine negative or positive? It's negative because it's only tan. So that means you're going to have that. Let's move on to cos quickly. So that means if you're having cos of 180 degrees plus that, you ask yourself, in which quadrant does that angle fall? It falls in that quadrant. Is this positive or negative? It's negative. Why? Because it's only cos which is that. So that means an answer to this is that. Let's quickly move on to tan and still use that same reduction form. So it's more like this thing, it's a formula. This thing, it's a formula. But we call it a reduction formula. Why? Because we use it to reduce a bigger angle to a smaller angle. So let's maybe see tan 180 degrees plus an angle. In which quadrant does that fall? It falls in that quadrant. Let's see. Is tan positive or negative? It's positive. So that is why for this one is going to be a positive that. So let's now try to be practical. I'm telling you, you guys do understand what I've done there. But in practice, Or in other words, it might not make sense. So I'm about to now be practical and say, let's talk about this. Let's say we are having sine of 220 degrees. These are the steps to follow. This thing, does it need to be reduced? That angle, does it need to be reduced? Yes or no? Okay, can this angle be reduced? Yes or no?
Yes, sir.
How do you know, Kabza?
Sir, the angle is not an acute angle.
100%. So this angle is bigger than 90, or this angle is not an acute. Therefore, it needs to be reduced. Okay, now that we know it can be reduced or it needs to be reduced, in which quadrant does that angle fall? Or what is the name of that angle?
Reflex.
Reflex, because it falls between 180 and 270. So that means between these two trig ratios, reduction formulas, the one for 180 degrees minus angle, or this one of 180 degrees plus an angle, you need to choose which one is going to be applicable. This one, it takes you to that angle of obtuse, and this one, it takes you to that angle of so it's more like the reduction formula that you're going to use is the one which says sine of 180 degrees plus what angle, what acute angle are you going to add to 180 so that it takes you back to that. So you'll always say 220 minus 180, whatever angle that you get. I think it's 40. Is it 40?
Yes.
Yes. So that means, can you see, you used a reduction formula to formulate this. So it's more like you haven't done anything. It's like you are having a P4. You just wrote it as a P into 2 plus 2. Because 2 plus 2, it still takes you back to a 4. Does it make sense, guys? Jackie, remember to
Yes,
mute your
it makes
mic,
sense.
honorable
Oh,
member. Once responded, make sure to mute. So let's see. Now, this is what you do. Can you see? It now looks as if it's that sine of 180 degrees plus an angle. So that means on reduction formulas, either that one of 180 plus or 180 minus angle theta, this angle is always acute angle. It's always acute angle. It's always an angle smaller than 90. So let's see. You do that same thing of saying in which quadrant. Obviously we know it falls in that quadrant. In this quadrant, is sine positive or negative? It's negative. So that means this thing is the same as negative sine 40 degrees. What I like about trigonometry is that over time I learned how to prove if my answer is wrong or correct. Punch this on a calculator and check if it gives you the same answer as you punch that. Punch it and let me know if it gives you the same answer.
Sir, it does not give the answer in like that form. It gives the answer in like, number form.
Yeah, so what do? You punch both and check if the number is the same. So we just try to check if the number is the same. So punch this. What are you getting as a number? and then also punch this, what are you getting as a number? Is it the same number or is it different number?
It's the same number, so just that the other one is negative and the other is positive.
Then it means something is wrong. Let me quickly check.
No, it's the same number.
It has to be
They are
the
both
same.
negative.
It has to be the same. I'm just wondering what honorable member could have got. Okay, maybe let me say this, Sean. At all the times, make sure your calculator it's in degrees. Hey, vuga malamba. Okay, uvugile malamba. Let's see. Remember, guys, it's load shedding on my side. So, okay, sine of 220 punch that, Sean, it's negative value, and then this one you punch negative sine 40. Negative sine 40, yes, is the same number. So let's very quickly do another example and see how far we can go with that. Let's say we are having tan of let's say 47. Here comes the question. Does that one need to be reduced? Yes or no? And why?
No, sir.
No, sir.
Why not?
Because it's an acute angle.
100%, because already this is an acute angle, so you don't need to reduce it. You just leave it as it is. Maybe let's look at this one. What about, let's say, cos of 105? Does this angle need to be reduced? Yes or no?
Yes, sir.
Okay,
Yes, sir.
obviously because it's greater than 90, or it's an obtuse angle. So that's when you can say in which quadrant does that angle fall? Obviously in the second quadrant. So that means you're going to say this is the same as you use this reduction formula. That takes you into that quadrant. So what is that number? Of which when you say 180 minus that number, it gives you that. So you just say this minus that and you'll get a number. Let's see, 180 minus 105, you get 75. So that means 180 degrees minus 75, it takes you back to that. So can you see? You haven't changed anything. So now, last step, you say, since it falls in the second quadrant, is cos positive or negative in the second quadrant? Obviously, cos is a negative. Then it means this is negative cos of 75 degrees. Then let's prove it. Punch this and also punch that. Check if it gives you the same value. If it does, then it's correct. Guys, are you winning there?
Yes, sir.
Is it the same answer?
Yes.
Yes, sir. Answer.
Okay, 100%. So I'm just going to remove all of that. The last one, I'll quickly do it. So let's say you are having tan of a 250, or maybe let me just say 253. So this is what you do. You say, yes, it needs to be reduced because it's not an acute angle. So that means you're going to say tan of a 180. Does it fall
Our dinner could receive on my side.
So I'm unsure if it is only me, but I can no longer hear you.
Bantu bakithi, I had my mic muted, and I was busy calling Gijas there, and Gijas was very, very close to come, and I was about to give you guys an opportunity to speak to Gijas, but my mic was muted, and you only told me late, and now Gijas is gone because he was waiting for you guys to speak. Okay, can you guys hear me now? Sean, it was me muted.
Yes, sir.
So remember, guys, anything strange happening, you let me know immediately because this is being recorded. You will need to catch up at a later stage. So let's make sure that we don't lose any information. Just to quickly take you through what I was discussing with our judges. I was saying we are looking at reduction formula along the x-axis. Later, we will look at reduction formula along the y-axis. So along the x-axis, we have this one of 180 degrees minus an angle, which takes us into that. And then we discussed this one of 180 degrees plus, which takes you into that quadrant. So the last one is this one of 360 degrees minus an angle, which takes you into this one. So can you see, we have along this line, the one that takes you there, and there, otherwise it's an acute angle. So let's see, the one for 360 is also easy, is the one which is 360 degrees minus an angle. That is the reduction. So maybe let's try to test it. That means you might be having sine of, let's say, 317. You ask yourself a question. Does this angle need to be reduced? Yes. In which quadrant does it fall? In the fourth quadrant. Is sine in the fourth quadrant? Whatever. Then that's how. But to follow all the steps, you're going to say sine. You use that reduction formula. What will be that number? Anyone can tell. Let's see. 360 minus 317 is 43. So that means 317 is the same as 360 minus 43. So can you now see you are using the reduction formula to reduce that angle to make it an acute angle. So is sine in this quadrant positive? It's negative. So that is why you're going to have negative sine of 43 degrees. So you are going to punch that, it gives you a value. You're going to punch that, it gives you a value. So what are you guys getting? Does it give you guys the same value when you punch both? Mm-hmm. Are you guys getting the same value? Am I muted? No. Are you still punching?
Yes, so we do get the same value.
This is the same value.
Okay, 100%. So I am now going to remove all of this. Let's maybe try another one. So let's say cos of 340 degrees. Does this angle need to be reduced? Yes. Why? Because it's not an acute angle. So that means it falls in which quadrant? That one. So this is the reduction formula that we're going to use. One for cos of 360 degrees minus what? I think minus 20 degrees. It is the one that gives you that. So is this thing positive or negative in that quadrant? I think it's positive. So that means this thing is the same as that. So last confirmation, does it give the same answer? Yes or no? Does it give the same answer?
Yes, it will give the same answer.
Okay, 100%. So now let's try to do some more problems. Let's try to do some more problems. I'm going to remove all of this and then summarize what we've just discussed. And you will realize that every time when you deal with this type of questions, you always need to remember this Cartesian plane, where you are having a cast diagram. You know, cos is positive here. All of them are positive. By all, I mean cos, tan, and sine. All the trig ratios are positive in there. So we know that if we have an angle which falls in this quadrant, we use that as reduction formula. If it falls in this quadrant, we use that as our reduction. If it falls in this quadrant, we use that as our reduction formula. This is all that you need in order to solve questions. So remember, this is an acute angle. So that is why we can actually say this is where you are having that acute angle. And in exam or in a test, they will give you something similar to this, but it's going to be a bit more complicated. Let's say they could give you this and say cos of 180 degrees plus an angle over cos of 180 degrees minus an angle. I'm not sure if there's anyone who can tell. With this type of problems, are we solving or are we simplifying?
So first you're gonna use the reduction formula. I don't know what to call that. As a solving.
But okay, noted, honorable member. Charlotte, I'm not sure if you want to guess that one, honorable member, whether we are solving or simplifying
We
there.
simplify.
100%. We simplify.
We simplify.
Kabza, remember, every time when you see an equal sign, this thing means you solve. But if there is no equal sign, you simplify. I'll just keep it simple, just so that you guys will always know what's going on. If you are given 2 plus x is equals to 1, because you see an equal sign, it means you must solve. What are you solving? You solve for x. So that is where you're going to say x is equals to transpose. It ends up being negative. So that means you are saying x is actually the same as -1. That is why when you say 2 plus and you take that -1 there and you punch this, it's going to give you 1. But now, if you are given 2x plus 1 minus x plus 7, do you see an equal sign there? No. What does it mean? It means you simplify. So that means when you simplify, you are given something which is long or complicated, and you need to rewrite it in its simplest form. That is why the word simplify. Make it simple. So that means you have two namunes that you can work out. So it's 2 namunes minus 1 namune. Just remain with 1 namune. You have a number being 1, you plus it with 8. Those are the numbers. You can work them out. You plus it with 7, it gives you that. Can you further simplify this thing? No, you can't. Then it means it ends there. So that means this thing, it is the same as that in its simplified form. So enough about that. Let's go back to our question. So that means here they are going to say simplify. It's more like they're saying rewrite this thing in its simplest form. So you do the same. Can you see? It's more like you are only having cos of 180 plus, and then you look at cos of 180 minus. So don't worry whether you are having things on top of each other there. What do you know about cos of 180 plus? In which quadrant does this angle fall?
Quad 3.
Is cos in quad 3 negative or positive?
So it's negative.
That is why you are going to say you are having negative cos angle over. Let's go to the bottom. In which quadrant does that angle fall?
The second quadrant, sir.
So is
Second.
cos positive or negative in that quadrant?
Negative.
Negative. So that is why you're going to have negative cos of an angle. So this thing, I think it can be further simplified because that obviously cancels that, and then that cancels that. So it's more like this thing is the same as a 1. I'm not sure if it makes sense, guys. Does it make sense to everyone what I've just done there?
Yes,
Yes, sir.
sir.
Yes, it does.
So very quickly, let me then teach you guys how to prove if your answer is wrong or correct. You are going to substitute whatever angle there. So some of you guys use angle as 30. Some of you guys use angle as 60. Maybe some you can use that angle theta as 45. So that means substitute 30 there and there. For the 60s, 60 there and there. 45, 45 there and there. It must give you 1. If it doesn't give you 1, it means you calculated incorrectly. You've done something wrong somewhere. So let's quickly do that and let me know if it gives you 1.
Yes, sir, it does give 1.
100%. Which angle did you use, Kapsa?
So I used 30.
Okay, so very quickly, let's try look at another example. So remember, guys, in case if you do not understand, in case if I'm losing you, let me know, but only if you attended from the start. So you will realize that sometimes you guys get confused easily simply because you missed some of the important information. That is why at school they always tell you not to miss a class. Not even a class, they always tell you not to be absent and make sure to be at school at all the times. Because if you miss an introduction, myself also, even your teacher, they won't re-explain what you missed the previous day at the cost of everyone's time. So that means for those who attended, we continue. Otherwise, if we re-explain, someone the next day they're going to be absent and then we have to re-explain. So we will spend the whole year re-explaining the same thing. So just make sure that you don't miss any of my lessons. Most importantly, make sure that at all the times you also don't bunk classes at school. So let's see. It looks like this. It looks like it's a bit difficult. It's a bit tricky. But I'm telling you guys, you just deal with that. You deal with that. You deal with that. It's more like you are having tan of 180 degrees plus an angle. You know how to work out this one. This one, we have also done it. You know how to work out this one. That one of tan, you know how to work out. So now they've combined them together. and they want you to simplify. So nothing tricky there, nothing complicated there. Let me quickly work it out from my side, and you will let me know if you understand. So you're going to say tan 180 plus in which quadrant? This quadrant. Is tan positive? Yes, it's positive. That is why we're going to say tan of angle. So can you see you have reduced it? So let's see. Sine 360 minus in which quadrant? In this quadrant. In this quadrant is sine -4, sine is negative. So because it's negative, write it inside the brackets. Most importantly, this is a negative and not a minus. That's where you guys make a mistake. So what about tan 360 minus angle? In which quadrant? In that quadrant. Is tan in this quadrant negative or it's negative? That is why inside the brackets you're going to say negative tan of an angle. Hey, can you guys see that this tan, it cancels with that one, and you can see that negative cancels with that negative. So it's more like in the end you are actually remaining with sine angle. So that means the whole of this thing in its simplified form is the same as sine angle. So again, punch all of this, testing with maybe 30 or 60. Let's always use either 30 or 60. Punch 30, 30, 30. Another one 60, 60, 60. Check whatever answer that you got. Then also punch that same angle there and check if it gives you the same angle or the same value. If it does, then you know you have done it correctly. 30, 30, 30, and then 30 there. Compare the answer that you get there, the answer that you get there. Check if it's the same. Are you guys still punching there? Otembele Pama. Are we together? Temba Batleye. Umza the Umis. Are we together, honorable member? I see Ufense is on the line. I'm not sure if you guys are following. Pennywell, Kwazi the Makwazis, Sean Perry. Are we still on the same page, guys? Or am I losing you?
I see it.
Why is it like you guys are planning a confidence of no motion against the honorable, the tutor guys? I don't trust you. When you guys are quiet, I know you are busy cooking a motion of no confidence there.
Sir, we are there. We are trying. We are doing it.
Okay, 100%. So what are you guys
So
getting? Are you
exactly
getting
the
the
same
same
answer.
answer?
Sir. It's a half. The same
Yes.
answer.
100%. So very quickly, I'm going to
It's
remove
fine.
all of this. So that's how you prove if your final answer is wrong or correct. It's not at all the times where you will be given a fraction. Sometimes they can give you something similar to that. Let's make it interesting and say that. And maybe let's say 360 degrees there and then that. So can you see? You might have been taught what I've taught you, but this is how examiner brings it. And it feels like, hey, I know. Seems like this one is difficult. But it's not. Still, you simplify. You can't do anything to one. That's why you just write it as one. But I'm telling you, just to keep things simple, this squared, it means two of the same thing. So that is why you can actually just say, maybe as a family, let's discuss this thing internally. Then at a later stage, this one, can we take them outside for a moment while we are still busy discussing as a family? In short, honorable members, I'm saying the moment you start having that, remember me saying, visitor, can you please wait for us outside while we discuss as a family? I hope it makes sense, honorable members. So remember, if you have sine of 30 degrees, mathematically, if you want to have a squared there, you can't write it as sine 30 degrees and then you do a squared there. Can you see? It looks a bit funny. That is why mathematicians said, no, let's not write it there, but write it there. But we know this is a visitor that can be taken outside, while as a family, we discuss our matters. I hope it makes perfect sense. So let's see. So that means you are having 1 minus. As a family matter, what is this thing? We know it falls in that quadrant. In this quadrant is tan negative or positive. I think it's negative. That is why you're going to say negative, and then you are now having a tan of an angle. So can you guys see? Doesn't matter whether those brackets are like that or like this. So you only have this type of brackets if you know you are going to have another brackets inside. That's how you mathematically write the brackets. If you are having x and you're still going to have, let's say, a plus 2 into, let's say, p, you don't do those, but that's when you do this type of brackets. But if you don't have the brackets inside, that's why you do these brackets. I hope that makes sense. So let's see. Now, this is what you are having. 1 minus. So remember a squared. A squared, it is the one that simply means a 2 of the same thing. So it's more like you can take it as a this squaring that, or you can take it as a 2 of the same thing being that. That is why you are therefore going to have this negative multiplying that negative, making it a positive already. And then you have tan angle multiplying tan angle. Then it makes 2 of those tan angle. Then in the end, or finally, this thing is actually the same as a that. I'm not sure if it makes sense, that one, guys, but I have a feeling that I lost you guys on that one. Before we prove it, anyone who's got a question on that? Before we prove it, anyone who's got a question on that? Kwazini. You don't have a question, honorable member?
Yeah, I'm fine.
Jack is fine. Temba Bahle, are you sure you don't have a question? Charlotte, are we okay that side, honorable member?
I have a question, sir.
No question from Temba's side.
I do not have a question.
Okay. No question. Okay. So, let's see. Maybe let's try to do some of these exercises very quickly. Let's try to have a look at this one. So that means you could have been given something similar to this still. 180 degrees plus that. I'm telling you guys, if you can correctly reduce that, even if it comes as a fraction or whatever, you will survive because you know how to interpret it or how to work it out. Let's maybe quickly try to work out that one. But maybe anyone would like to suggest how to work out that one, having a square. The only difference is that one, it has a square there. Anyone would like to suggest how we work it out? Mhm. Anyone who would like to suggest how we work out that one?
So I cannot see what's happening on the board.
Is it everyone who's not able to see?
Yes, you
Yes.
can see screen.
Okay, let me leave and then I'll be back. Kabza, make sure that you write a list of noisemakers. While I'm out, you guys don't make some noise. Okay, let's see. How about now? Still the same. I think it's still the same.
No, that's not still
Let's
the
see.
same. It has changed.
Huh? Can you see now? But me, I
Yes,
can't
sir.
see. Oh, there. Uh, hi. It's not make sure. Let me try it again.
Not well,
Now,
not very well.
now I can see. Can you guys see?
Mm. Yeah, it's okay.
Check the jaggies. Can you see now?
Yes, me, I can see.
Okay. Anyone who would like to try that one? Remember, whether it's wrong or correct, me, I do not care. As long as you can say something that is very much positive, and I welcome any input. Wrong or correct, I do not care at all. Anyone would like to give it a try? Maybe let me do this one. This is where you say, visitor, can you maybe temporarily go outside so that we discuss as a family? Can you guys see? Then, in which quadrant does that fall? In this quadrant. Is cos negative or positive? You know cos is negative in that quadrant. So that means this is what you are having. So always when you have a negative whatever squared, this squared, it actually removes that negative. Then you just have a positive that. So that means this one, it ends as that. Does it make sense, guys? Or am I losing you on that one? Hmm?
It does make sense, sir.
But does it make sense to everyone, or is it only making sense to Kabza there?
It makes sense.
100%. Let's quickly do the last one, and then from there, we will move on to some more complicated stuff, and that will conclude our lesson for today. So that means, in case if you've got any question, just make sure to ask while you still have a chance. But most importantly, we are still going to be doing all of these in our Monfry lesson. So it's not at all the times where something makes sense first time. So when we do it again, it will make sense. So let's see. What about this one? And remember, Sean, this stuff is not meant for you, honorable member, but don't be surprised when you understand. It's because nothing is difficult. If something is well explained, whether you're in primary or wherever, as long as it makes sense, you will understand it. I can tell you now, Sean, I can take you to varsity. and put you in a class, if something is well explained, you will understand it. You might not fail to attack the questions because it's not at your level. But in terms of you understanding, it's an indication that nothing is difficult. As long as it's well explained, you will understand it. So, let's see. Anyone would like to give it a try?
Yes.
I'm not sure
Yes.
if Sean is saying he wants to give it a try with that yes. But anyone would like to give it a try, mention your name, then I will know you want to give it a try.
So
Jakey.
you've shown a chance.
Oh, you choose Sean, sir.
Yes.
Sean, okay, Sean, everyone is mentioning your name. I think they want you to give it a try. Do you want to give it a try, Sean?
Yes. So I
Okay.
think you take the two outside and put negatives in
Hey,
a bracket.
Sean, are
Get the
you
360
American?
minus X.
Are you American, bro?
No,
Mm-hmm. But it's fine. Let's speak American. What are you saying, bro? Mm-hmm.
is make a big bracket and put in negative sin, then a small bracket put in 360 minus angle, then close it, then close the big bracket and square it.
Hey, man, what are we doing, bro? What's next,
Uh,
bro?
uh, uh, we're looking for like the 360 again.
Yeah, bro.
Yes. So sin will be negative if I'm not mistaken because yeah, yes, it's
Hey,
negative
it's not
sin.
make sure.
It's
What am I
not.
writing, bro? Hey, why is it like Sean went to America now? Sean, are you the airport honorable member? Seems like Sean is running away now.
He's not
Or
certain,
maybe
sir.
it's me. Huh?
He's not certain. He's not certain, sir.
Oh, okay. Okay. No, then it's fine. Sean, let's continue. You'll just let me. You'll just tell me what to write. Hey, Sean is gone. I think Sean is experiencing some poor network that side. He's got his mic unmuted, but I can't hear him. I'm not sure who else wanted to. I think Jakey wanted to give it. Jakey, can you continue from here, honorable member? I think Sean was onto something there.
Yes, sir. Can I try?
Yes, give it a try.
The sign for the sin will be positive.
Okay, what am I writing?
Plus sign.
Mm-hmm.
So where's the sign? The sinus.
Wait, what are you saying, honorable member?
I don't know. I'm not sure, but I don't know if we can restart it.
Oh, yes. No, we can.
This answer, is
Let's
it
start.
correct? The one Sean gave us is correct.
Hey,
Is
me
it
too. I'm not
okay?
sure on that one, honorable member. Hey, it's not make sure that one. It's an
Okay,
American.
let's.
Okay, continue.
I don't know.
Hey,
Okay.
Charlotte. You know what's the problem here? I'm telling you, the only problem you guys are facing, I
The
think, is that
minor.
negative which is confusing you guys. Um,
Mm.
Imagine in exam, that negative makes your life difficult. Let me quickly work it out, honorable members. Let me work it out. Then we'll see where we end. Let's say that negative as a visitor and also that as a visitor. Can we try to discuss our own issues? Let's maybe put it outside and let's say that and what else? That minus that. And then we do that. Why am I doing this? It's so that I can easily work out that. Huh? Did I do it correctly? Yes. So now let's see. Let's see. We have that negative. Now we can work out this thing. In which quadrant? In the fourth quadrant. Is this thing positive or negative? It's negative. That is why you're going to say that. Now you have that. Can you see? So you know that this squared, it makes that to be positive. So that means you still have that negative. And then you also have that positive sign angle. So it's more like this thing, it ends as that. Maybe let's try to prove it. There, let's punch 30, some punch 60. Then also there, we are going to punch 30. For those with 60, punch 60. Let's see if we get the same answer. Yeah, hey, this one, I can hello. I come back.
And your screen is not on, sir.
I'm not sure if you can screen the screen. Hello, I come back. Let's see. I think now it's fine. Can someone confirm? Innocent,
Yes, sir.
can you remember to mute your mic, honorable member? Guys, can you see there?
Yes, sir.
Okay, 100%. Innocent,
What the
click on a
Now the
button
view
which
was
says
not shown.
mute.
Is
Innocent.
what's wrong? Or is my phone wrong or what?
Okay, I'm going to mute honorable member from my side. Muted. Okay. What are you guys getting when you punch that one? So this is how you punch it, because I know also to punch it, it could be another issue. So you punch it at this stage. That's how you punch it. So that means you are going to put that negative on the outside and say negative. You open a bracket, you say sign. Let's see. Sign 360. Let me use 30. You close again, then you square it. It's equals to, I'm getting -1/4. Let me try this one. So you're going to say negative, open, sign. I use 30, you close, you squared. -1/4. Hey! Hey! Why is it like my young sisters are not happy? Okay. Guys, what are you getting? Are you also getting the same answer?
Yes, sir.
100%.
Yes, sir.
100%. So that's how you work out that one. The only issue there, it was that negative. I deliberately brought that one having a negative just to spice things yana there. So let's do the last one, and then that will conclude our lesson for today. Maybe let me try to work it out myself, and you guys will let me know if it makes sense. You might be given something similar to that. But I think this one is going to be easy, guys. I think this one shall be Mantlik. Yeah, I think this one. I think this one shall be Mantlik. I'm not sure of that Afrikaans, but I know what I'm saying. Ek weet, yeah. You get it. If you don't get it, forget about it. So let's see. It's more like you're given this, that, and that. So sine 180 plus, in which quadrant is that one? Is sine positive? It's negative. That is why inside the brackets you're going to say a negative sine angle times you do this one. In that quadrant, is this thing negative? It's negative because it's only sine which is. So that is why inside the brackets you're having negative cos angle over this one. In which quadrant? In that quadrant. Is this positive? It's negative. That is why you're going to have it as negative. This one. In that, wait, which quadrant? That one. Is this simple? Yes, it's positive. That is why you just write it as that. I think we have some things cancelling there. This one cancels with that, and then you have that negative cancelling with that, and then you have this cancelling with that. You have that negative. So it's more like in the end, you end up having -1 as your final answer. And then to prove it, you can substitute same angle there, and check if finally you get -1. If you do, then you know it's done. Did I not lose you guys on that one? Hmm? Did I not lose you on that one, honorable members?
That's we are fine.
100%. This is the one that I'm going to give to you to work it out. So, the code for today's lesson, just mention. No. Yes, just choose either sine, cos, or tan as the code for today's lesson. So you can just comment sine, cos, or tan. This is so that we know who has attended today's lesson, and that's how your parents track if you are attending lessons or not. So that is actually the register. You just comment with sign, cos, or tan. So this is the one that I want to give you guys to work it out. Sine squared into 360 degrees minus an angle, all of that divided by sine angle multiplying sine of 180 degrees plus an angle. So write it down, simplify that one, and then from there, you will get your final answer. Yeah, I think maybe after you got your final answer, you can just send me an inbox. I'll send you guys a link. So that link is the same that you submit your tests. So it's that inbox. I'll send you guys a link to say to submit. Click on this link. So you're just going to tell me what that final answer is. If it's 1, just say 1. If it's 2, say 2. But also, don't just say 2. I think don't just say 2. Take a photo of your calculation, and then you just send me a photo. Don't text a text. You work it out, you take a photo, and then you send a photo, just like when you submit your tests. Did that make sense to everyone, honorable members? On our next lesson, we will be looking at reduction formulas along the y-axis, because that one, it works a bit different. There's going to be some interesting stuff there. But for now, did you guys understand what is expected of you on that one?
Yes, sir.
Okay, 100%. Any last question before I sign out, honorable members? Any question before I sign out? Sean, are you sure
So
you
must
don't
I
have a
also do it,
question?
or should I just leave it?
Sean, can you say that again, honorable member? I couldn't get that. What did you say?
So
No,
I
I
was
think it's fine.
asking if I should also
Yeah.
do it, or should I just leave it?
No. For you, it's fine, honorable member. For you, it's fine. Don't worry that much about it. Let's say it's optional. You can either work it out, or otherwise, from here, you can go to watch a TV short. But as for the honorable members, they need to just quickly work it out. You take a photo. I'm going to send you a link, of which you click on that link. It's going to open an inbox where you will submit that answer. The same way you submit your tests, you do the same. I see someone has already sent, but I think no one has got a question. Let me check. I see Simo Duplessis has joined. Simo, it's unfortunate. It seems like you are late for today's lesson, but did you get something out of today's lesson, or were you completely late? No, honorable member is gone. Okay, it's fine. I'm about to sign out. Temba, can I leave, honorable member?
Yeah. Everything is fine.
Hayi, Temba wakora, hayi. Sengikhathele manje. Sengikhathele, ungahamba. Ladies and gentlemen, thanks very much for joining. You guys have a very good night. My name is Desmond.
Hey, wait.
And